This is Brad here at ANU, and we hear a lot about exploring the solar system and going to different planets, but it's not as simple as that. It takes time. Jamie here is going to chat with Adam and Lish about how actually we explore our solar system.
Thanks, Brad. So today I'm here to talk to you basically about the distances in our solar system and why that helps us or hinders us when we're trying to explore. So first, we have our nice sun here. Hi, sun.
Hello, sun. You're looking shiny today.
So we'll just place this sun here in the center of our solar system. And you, Lish, you're looking down to Earth today. How would you like to be on Earth?
Perfect.
Great. So do you know the distance between yourself and the sun?
No idea.
No idea. It's a massive distance. It's 150 million kilometers away between the sun and you, Lish, which is really big distance considering the light from the sun only travels at 300,000 kilometers per second to get to you.
It's really fast.
Very fast. So given that we know that the distance between the sun and you, Lish, is 150 million kilometers, and the light from the sun travels at 300,000 kilometers per second, how long do you reckon it would take the sun to get from the light from the sun to get from the sun to you?
My brain cannot compute that, but maybe a couple of minutes?
Yes, that's a very close answer. So it takes 8 minutes for the light to travel from the sun to you. So for example, if the sun was to disappear, we wouldn't realize it for 8 minutes, which is a really long time.
So that's very well and good for the Earth, but what about another planet, say Mars, Jamie?
Oh, I knew you'd bring that up, Adam, since everybody wants to go to Mars these days. But what distance do you reckon is between Lish on Earth and you on Mars?
Would have to be tens of millions of kilometres, but I really don't know.
Yeah, but that is really good. You're in the neighbourhood. It's an additional 75 million kilometres between Lish on Earth and you on Mars. So for example, if we use roughly the sun, Lish is there, then you, Adam, slightly a bit more. That's roughly the distance. Okay, maybe slightly closer. Yes.
So half the distance again.
Half the distance. And since we know it's half the distance and light takes 8 minutes to travel from the sun to you, Lish, it will just take another 4 minutes to travel to you, Adam. All right, but this isn't the only way the planets are arranged in the solar system. For example, as the planets rotate around the solar system, so Adam, you, for example, rotate nice and easily on the other side of the solar system. You're a lot further now. So knowing that the sun and Lish, you're still at 150 million kilometers, but Adam has now moved all the way to the other side, do we know the distance between you, Lish, and you, Adam?
It would be a lot further, hundreds of millions of kilometres or so.
Yeah, so that's right. So 450 million kilometers between you guys now. And say you were trying to have a video call. So Adam, if you could just wave to Lish all the way.
I'm getting nothing.
You're getting nothing, basically. You have to wait for 24 minutes before something happens, something arrives, because of the massive distances. And to show this today, we have a nice little RC car. So we'll just pretend, here you go, Adam, to put on Mars.
I love a new toy. Shall I turn it on?
Yes, that's a very good idea. And then Lish, a remote to control the car. We just switch it on. So give it a go. Oh no, nothing's happening. Broken. Or maybe it's the distance between them.
Because it's going to take a long time for this signal to get all the way up to Mars, where Adam is.
Exactly.
To power it. 24 minutes.
24 minutes, exactly.
What
should we do? Whoa. What was that?
You'll just stand through.
Oh, I guess 24 minutes must have passed. Geez, we can really see that even going just from Earth to Mars, it's a really long distance. And so this signal delay is why we need things such as the Curiosity rover on Mars. And this is also why, as we go further away from Earth, these kind of things become harder and harder.